All right, so moving into the second part of our lesson where we are using and writing inequalities with more than one variable. Here's a balance hanger for you. And you'll notice, or what do you notice about this balance hanger? What's different about it to the ones that we saw in the last unit? What you should notice is that it is not equal. All right, our balance hanger is not in balance. So if something is not equal, we have an inequality here. We do not have an equation. We have an inequality. It is not equal. So here, let's say the pentagon is P and the circle is C. Write an inequality that is represented by this hanger. Well, I can see if something is heavier, it's going to go down. Okay, the C is obviously heavier than the pentagon. That was a terrible C. The C is a greater weight than the P, or we could write that P is less than C. The circle weighs 12 ounces. Okay, great. Let's go and add that information now to our diagram. The circle weighs 12. Use this information to write another inequality to represent the relationship of the weights. Then describe what this inequality means. Okay, so now instead of C, we're going to change it for 12. So now we have that 12 is obviously greater than P, and P is going to be less than 12. What does that mean? Well, it means that P must have a weight that is less than 12. It cannot be equal to 12. Let's see, does the question ask us to graph it? Yes. So if the circle weighs 12 ounces, graph the inequality for P. Okay, so first I need my circles. Which one am I going to use? Colored or not colored? I'm going to use a non-colored one because 12 is not a solution. So I'm going to find 12. And 12 is greater than P, or P is less than 12. So both of those inequalities I'm going to graph here. Now I'm also going to stop at 0. Again, 0 cannot be a solution because you can't have a 0 weight. Something with 0 weight doesn't exist. So what are some possible values for P? Well, P could be 11, could be 6, might even be 7.5. We might even have some decimals. It could weigh 0.0001 ounces, but it cannot weigh 0. All right. Use the graph above to determine if each of the following can be a solution for P. All right, 12. Can 12 be a solution? Well, let's look at our chart. And 12 is actually represented by an open circle here. And so no, 12 is not a solution. All right, the weight of the pentagon must be less than 12. Otherwise, our hanger wouldn't look like that. 3.5. Let's find 3.5. 1, 2, 3.5. Is it on our line? Yes. 0.05. Is it on our line? 0.05 is probably going to be really close to 0, but it is still going to be a solution here. Yes. -5. Well, no, ours is going to stop at 0. We can't have a negative weight, so that is not true. 23. All right, 23 is all the way up here. That's not on our inequality graph, so no, not a solution. 12.001. Well, it's going to be just a little bit higher than 12, and it is not a solution either. Okay, Eleanor writes this inequality to represent this balance hanger. P plus C less than S, where P is the pentagon, C is the circle, and S is the square. Let's see what she's done wrong. C plus P is obviously this side. And she said that it weighs less than S. Well, that's incorrect because if C plus P weighed less than S, our balance hanger would be the opposite way. The S would be down and the C and P would be up. All right, because the S is going to weigh more. So she's clearly wrong, poor Eleanor. What she should have written was that C plus P is greater than S, because C and P together have a greater weight than the S. All right, let's determine some possible values for each shape that makes our inequality correct. We're actually going to use the correct one here, where C plus P is greater than